Welcome to our final presentation for the NAII AI Tech Sprint Interventions for Veterans Not Currently Served by the VA. My name is Bob Calco, Chief Architect and Lead Developer for Apex Data Solutions. Our subject matter experts, Dr. Jorge Ferrer of the Department of Veterans Affairs and Dr. Roger Boudou of the Department of Defense, have both provided outstanding support and guidance throughout, and we thank them for that. We are proud to present to you this Sprint Zero demonstration of our provider directory use case, highlighting the use of blockchain technology as a key component of a platform for general data interoperability. Before we proceed, I want to give a very high-level overview of our use case, which is tackling the well-known industry problem of inaccurate provider directories. This problem affects consumers, providers, and payers in a number of adverse ways, ranging from burdensome costs to untimely access to care. Why is this an important use case? Provider directories are important tools used by consumers, providers, and payers. Consumers use provider directories to select health plan products, seek care, and avoid surprise billing occurrences. Payers and providers produce directories and use them to process payments, detect fraud and abuse, validate credentials, exchange clinical information, manage and coordinate care, and develop insurance products. Regulators and government agencies rely on provider directories to oversee networks and health plan products to ensure compliance and to license providers. Inaccurate provider directories negatively impact every one of these areas. These costs manifest themselves in many ways, not the least of which being an immense administrative burden, particularly considering the process of updating this information is neither uniform nor particularly modern. Providers feel bombarded by diverse lines of business across multiple payers with whom they have a professional relationship. This on average numbers around 20, each of them demanding physicians update their information in different ways. Inaccurate provider data impacts everyone. Consumers incur delays in accessing care, surprise billing, and higher out-of-pocket costs when listed providers are no longer in network. Provider practices incur costs on average of $63,000 annually on directory maintenance matters. Payers incur high administrative costs associated with their own efforts to collect provider data and update their internal systems of record in order to publish updated and accurate provider directories. Annual costs incurred by payers and providers exceed $2.76 billion annually. To make things even more urgent for the industry, the recently passed No Surprises Act imposes more complex requirements and stiffer penalties for failing to solve this problem. Under the Act, payers and providers must meet heightened update requirements and must be able to prove compliance through mandatory regular auditing. Neither payers nor providers are currently capable of meeting these statutory requirements, and this is the central focus of our current innovation Sprint use case. Our approach to using blockchain also provides an auditability feature to support oversight mandates. The problem is twofold. Ensure the key data elements are up to date at all times and be able to prove it on a variety of diverse verification frequencies. A near real-time solution with full audit-ready transparency is desperately needed. This is precisely what we're working on. The first principle of this is that given a single source of truth, is there a non-obtrusive way to bring diverse systems of record into information alignment, meaning that they have at a given point in time the same information regardless of database-specific nuances or application-specific requirements. A novel use of blockchain is used for this purpose, based on a metaphor that is different from the distributed ledger metaphor of conventional blockchain that in our experience unnecessarily complicates efforts to leverage blockchain in healthcare. Rather than attempt to get systems of record to quote-unquote talk to each other, so to speak, our approach is architectural in nature, not API transactional. This means that each SOR does not need to know about, much less communicate directly with, any other system of record. So this is the second principle, that interop should be part of the woodwork of things, a layer in every enterprise architecture, and most definitely not point-to-point. Another hidden benefit of this approach is that, given the industry investment in big data, it provides many logical entry points where AI technology and techniques can be introduced to solve domain-specific problems. This sprint is scoped narrowly, but is still fairly ambitious. The objective in Sprint Zero was to lay the foundation for subsequent sprints and pilots with an eye toward leveraging AI in multiple entry points across the architecture. We believe we've achieved that objective. Okay, so now let's show you what we have accomplished during this use case sprint and where we think this can go longer term. In this demo, you will see 3 heterogeneous systems implemented on different database stacks come into alignment as soon as one of them changes information about a provider. The source of this information could, in our solution, come directly from the provider in a standalone tool provided to them, or it can come by in any number of automated or manual business processes. Finally, before we start, let's take a quick look at the current state of the art. Currently, payers use batch updates to roll out changes from master databases to their lines of business. From their point of view, anything that makes these updates real-time would be a huge improvement. But we believe the goal should be real interoperability, not just timely updates. And that's what you're going to see now. So what we have here are 3 distinct databases on different database platforms, each with their own web front ends. And in this demo, you will witness live, real-time interoperability between them as we update a provider record in the master database and watch as the 2 downstream systems of record that also contain a record related to the same provider are updated. We'll try to make this brief so that we can spend more time on the visual explanation that follows. First, we will open up the master front end, and we'll locate the common provider. And we can see that it's a neurologist, occupational therapist, we see a license, we got some information about various services. Let's go ahead and open the same provider up in the other 2 front ends, one for TRICARE and the other emulating VA Choice. And we can see that they have roughly the same information despite some cosmetic differences of layout and look feel. What we'll do now is make a trivial edit to a couple of edits to Reddy's record. Change the first name. We will add a specialty. And we'll add a license. And now we'll watch some updates in the background. Okay, what just happened is that they came into alignment. We can verify this by refreshing. Okay, we see the edits have been applied to the TRICARE MySQL database. And we can see that they've also been applied to the Mongo database behind VA Choice. So now they're all instantly in alignment. With that, I'll get back to the slide. Okay, now that you witnessed real-time interop with your own eyes, let me quickly walk you through how that worked and what those log messages were conveying a little bit more visually. Let me just put a little laser pointer on here. So when we updated Sunil Reddy's record in the master UI, it went through the Postgres API to talk to the Postgres database and update it. The master domain adapter detected the change, notified the transactor. The transactor updated long-term storage, which is the blockchain and all the associated information with that. That then notified the domain cache that a record, or actually several records, had been updated. And these notified Apex Synchronicity, the synchronizer, which in turn notified the adapters for all 3 systems. The first of which, recognizing it was the original provenance, skipped it, and the other 2 applied the changes to their databases. And notice that there's no communication occurring between these systems directly, which is the point. In this diagram, we're going to see what happens when you connect transactors. In this case, imagine each circle is an organization, such as the VA, the DoD, or CMS. The important point isn't who or how many circles, but how they are connected via the ForeverDB transactor component described in the previous diagram. Each circle represents a full instance of Unify, including all the components and anywhere from 1 to n systems of record that need to be aligned in real time. So imagine a change to any system of record in any of these circles propagating to all the other systems of record in all the other circles. Our blockchain-based process for building local copies of a single source of truth per identity that's suitable for this low-touch alignment of each system of record is a completely new way to visualize interop, and we hope you find it as fascinating and potentially game-changing as we do. The tools we are using to implement this use case demo are designed to facilitate legacy application modernization in support of a general purpose data interoperability capability. Blockchain is used primarily to facilitate the construction of a single authoritative distributed source of truth suitable for a system of record alignment. Data sharing and external alignment occurs via distributed transactor. Generalized, this approach to interop can be extended to address other interop problem areas such as prior authorization and consent, and the sharing of clinical data across organizational boundaries and between and across disparate systems of record. Some examples of AI entry points in the architecture include the transactor for intelligent identity resolution and linking. Here we can imagine evolutionary neural networks and other forms of real-time learning to improve resolution and linking of identities across disparate systems with practice. The domain cache, we can see use of intelligent state reconstruction over time and real-time discrepancy detection. This can include deciding whether a discrepancy between different systems can be fixed automatically or whether it needs to be resolved in a manual or semi-manual reconciliation workflow. In the domain cache, we also see a potential for integrating clinical decision support, kind of plug-and-play AI use case for the platform. We have a vendor of such a system out of Canada that sees our platform as a way to avoid having to create integrations directly with EHRs, and they're right. If they speak the language of the domain, our platform takes care of actual integration with all the systems of record across the entire enterprise. So the barrier to entry for them now only involves integration with just two components, the domain cache for reads and the transactor for writes, the same as any other adapter actually. Finally, there's the long-term storage. We see this as a black box flight recorder, and we can see the potential for virtually limitless machine learning and BI applications. Our prior work on medication reconciliation projects at the VA allowed us to use this idea to decouple UX-related analytics from the actual user interface code. This itself is an excellent ML use case. There are other touch points, but we consider these the most potentially valuable going forward. This concludes our presentation. I will now very happily take any questions that you may have.